So a little Sunday goofing around. I got this made out of aluminum, slowly turning the 3D printed parts into actual aluminum pieces. I thought I'd show you the difference here. So this was the printer port. I'm using encoders back through the printer port, and then I'm using pulse width modulated drives. These are just some drives I got off of Amazon. So the printer port's outputting pulse width modulation, pulse density modulation, and that's what's running this servo. So you can see, because it's the printer port, you can hear with me trying to force it back and forth, it fights back. So the limitation is really, how fast the base thread is in the real time. I don't remember what this is, but my maximum feed rate is around 60 inches per minute is about the limit. And I would, if this was running production, I'd probably cut it down a little bit, but still it's over twice as fast as what the original MCO did with the steppers. So I'm gonna home it here. You can see the home switch. So now I'm gonna run a program that just runs it back and forth at its maximum feed rate. You can see it's 66 inches per minute. So this is what I'd use for tuning. But yeah, 66 inches per minute is about the limit of this setup with this encoder, and the real time, how quick I can run the base thread on this computer, which is right there. So that's kind of cool. So closed loop servo through the printer port. That's pretty awesome. So now I have been goofing around with a Mesa. I don't know if I can do this holding the camera, but I have another config that I started setting up using the Mesa hardware, so you can kind of see the difference of what moving some of the heavy lifting off, like the encoder counting and the pulse width modulation to an external device. So I'm gonna stop this. I'm actually just going to close this program. And let's see if I can do this one-handed. Who screws these things in? It was me. I screwed it in. Hold on. I'm going to set you down just for a second. All right. So I plugged the cable into this, which goes to there. Now I'm going to launch linuxcnc with the Mesa config. All right, so I'm going to home it. All right, so now if we run the same program, I'm going to load, wrong, the tuning program. All right, you ready for this? So that is 250 inches per minute with the same hardware, because I can count the encoders faster. And plus you don't hear the servo as much because the frequency is much higher. So 250 inches per minute, probably way faster than it should be. But it sounds good. If we run health scope, you can take a look at So this is following air here. And we're getting maybe 4/10 or 3/10 of a thousandth of an inch of following air. So pretty happy with that, and that's at, you know, shuttle speeds. You wouldn't be probably cutting at that speed, but the acceleration is set to 60 inches per second squared. You could probably up it a little bit, it looks like, because the spike isn't too bad at the beginning of that. The red here, if that's red, is the acceleration command, and it's, you know, bang bang acceleration. So yeah, pretty darn happy with that. So you can see the difference, you know, the printer port works, but holy crap, a $100 or whatever price card this is makes it that much better. Plus with this card you could use your breakout board because it kind of has the same I/O as a printer port, but Mesa also has a shit ton of daughter boards that are way more capable than that. So yeah, there we go. 250 inches per minute. All right, talk to you guys later.